We are converting the chapter force into the form of question answer, and this is 5th class, and we are starting with question number 52 because till 51 answered in previous class. A large stone of 20 kg and a small stone of 5 kg are dropped simultaneously from certain height. Which one reaches on the ground first? Why? What do you think? So answer is like this. Both of them reach simultaneously on the ground because acceleration due to gravity is same for every object irrespective of their mass. Okay, next. Tides rise in the sea. Why? The reason is very simple. Tides rise in the sea due to the gravitational force of moon acting on the sea water. Next. When a feather and a coin are dropped towards the surface of the earth, do they reach the ground together? If this experiment is done in moon, what difference can be occurred? Write down with reason or write with reason. If it is so, then we can answer this way. Feather and coin doesn't fall together on the surface of the earth due to the air resistance. Okay. They fall together on the surface of the moon due to the lack of air resistance because acceleration due to gravity is same for every substance. It does not depend on the mass of the body. Okay, let's go to next question. 55. In which condition will acceleration due to gravity of parachute be zero? If a person is in parachute, then in which condition while coming down on the surface of the earth, the acceleration will be zero? When the air resistance neutralizes the gravity of the earth acting on the parachute, then the acceleration due to gravity will be zero. Okay, next question. The effect of gravitation is more in liquid than in solid. Why? Molecules of liquid are held loosely, but the molecule of solid held tightly. So, the effect of gravitation appears more in liquid than in solid, and it will be more in gas than that of the liquid also, but this is not in question. Okay, let's go to another. Write the main conclusion of Galileo's feather and coin experiment. What is this conclusion? Conclusion of feather and coin experiment. Acceleration due to gravity for every substance is same irrespective of their mass. Okay, now next. In which direction does the force of gravity act? Force of gravity act towards the center of the earth. Very short question, short answer. Next, why do the satellite not fall while revolving around the earth? The force of attraction of earth acting on the satellite provides the centripetal force which rotates the satellite around the earth. Velocity of the satellite provides the essential centrifugal force which acts opposite to the centripetal force. Thus, two equal and opposite forces, that is centripetal force and centrifugal force acting on the satellite, balances the satellite and it does not fall. Very interesting. Now next question. Write one effect seen on the sea due to the gravitation of the moon and the sun. Actually, this question is repeated, but there are different examination, and according to SE examination, same question is asked in different ways. That's why the question is repeating in different ways. Rise and fall of level of water in the sea, that is tide, appears in the sea due to the gravitational force of sun and moon. Okay, again, where does the weight of a body become maximum in Nepal? Why? Why this country is told? Because Nepal has different types of land, one Himalayan range and then Mahabharat range and then Tarai region. That's why this question may be very suitable for Nepal. So, where does the weight of a body become maximum in Nepal is very suitable. Weight of a body will be maximum in Tarai region of Nepal. Radius of earth is less at Tarai region because it is low land of Nepal. Acceleration due to gravity g is inversely proportional to the square of the radius of the earth. This is the symbolical representation, and so g is more at Tarai region. Weight of a body is the product of mass and g, w equal to mg, and so the product of mass and g, that is the weight of the body, is maximum in Tarai region of Nepal. Mass remains same. If g is more, then weight will be more. Okay, next. Why does a sheet of paper fall later on the earth's surface than that the paper ball of equal weight if thrown from a certain height? It's interesting. Surface area of a sheet of paper is very high than a paper ball. Since air resistance increases with the increase of surface area, hence the air resistance on the sheet of paper will be more, which acts against the gravity of the earth. Therefore, the sheet of paper falls later than the paper ball. Let's go to another question. Where does the weight of a body become maximum on the surface of the earth? Weight of a body will be maximum at the pole of the earth. Next, a satellite does not need any energy to revolve around the earth. Why? A body moving in the circular path requires a centripetal force to revolve around the central point. Gravitational force of the earth acting on the satellite provides essential centripetal force to the satellite to revolve around the earth. So, satellite doesn't need any energy to revolve around the earth. Very interesting. Next question. What effect will be on acceleration due to gravity if radius of the earth is decreased? It means radius is decreased without the change in mass. We have to understand this way. Answer will be, if the radius of the earth is decreased with the same mass, then the acceleration due to gravity will increase. Because we know that acceleration due to gravity is inversely proportional to the square of the radius of the earth, and if radius is less, then g, acceleration due to gravity, will be more. Okay, next question. At what condition the value of acceleration due to gravity is approximately 0 while getting down from parachute? When the air resistance neutralizes the gravity of the earth acting on the paratrooper, then the parachute falls with the uniform velocity. Then the acceleration due to gravity will be approximately 0. Okay, next. We do not get hot when we jump with parachute. Why? Parachute has huge surface area, so air resistance becomes very high, due to which gravity of the earth acting on the paratrooper is neutralized. So the body of paratrooper does not accelerate but fall with uniform velocity and landing will be safe. Okay, next question. The probability of getting hurt is more when a man jumps from greatest height. Why? Or great height. Why? When a man jumps from greatest height, his body accelerates with the acceleration due to gravity, that is g. Velocity increases due to the acceleration, which also increases the momentum of his body. Ground stops his body abruptly by applying reaction force. According to Newton's second law of motion, force is directly proportional to the rate of change of momentum. Since his body is stopped abruptly, so the rate of change of momentum is very high, and therefore the force applied by the ground to stop his body will also be high, which hurts him a lot. Therefore, the probability of getting hurt is very high. Okay, let's go to next question. What is the difference between fall of parachute on the earth and that on the moon? Moon doesn't have air, so parachute falls with the acceleration due to gravity of the moon and the landing is not safe. But earth has air and due to air resistance, parachute falls with the uniform motion, so landing is safe. Okay. Next question. At what condition a coin and feather fall together? What is the acceleration of the feather and the coin at that instant? Justify your answer. We can say this way: coin and feather fall together in the condition of free fall, which is possible in vacuum only, where there is no air resistance. Acceleration is equal to the acceleration due to gravity, small g, that is 9.8 meter per second square. Because according to the law of falling body, every body falls with equal rapidity in vacuum irrespective of their mass, that is, acceleration due to gravity for every falling body is same. Okay, let's go to next. It is difficult to lift a large stone on the surface of the earth but easy to lift small one. Why? The force required to lift a body on the surface of the earth is equal to the weight of the body. Weight of a body is the product of its mass and g. W equal to mg. We know this. Since mass of a large stone is greater than the small stone, so the weight of large stone is more and it requires more force to lift and it is difficult. Okay, this much for today. I think I converted the whole chapter force into the form of question answer. Now, next class we'll go through numerical problems. Okay, this much for today.